Friday before break. Some of those double angle identities. We also talk about these like power reducing identities, stuff like that. But your homework hopefully gave you a good opportunity to practice some of those ideas. Well, today, before you leave, hopefully you'll be able to do the following. It says right here that students will be able to express the following expression: a cosine x plus b sine x as c cosine of x minus d, where a, b, c, and d are all constants. That's our goal for today. If that doesn't get you up in the morning, I don't know what will. I mean, that's a very exciting objective, when you agree. Hearing great excitement. Let's launch right in. All right. So, by the way, and this is like, we're kind of coming to the end of the semester here too, aren't we? We're kind of coming in. This is the penultimate lesson of this unit and of this semester. This is like the question that motivates our discussion today. Maybe you can tell me, please, why you would want to ask this question. Can you think of some context where this might be true, where you might like this information? 3 cosine of x minus 4 sine of x. I claim today that we can rewrite that in this form over here as just like a number times a cosine of x minus a number. Again, c and d here just represent numbers. Why? Can you think of a reason why you might want to ask and answer that question before we? I mean, we will get to the place where we can answer this very soon here and rewrite it that way. Can you think of a reason why you would want to rewrite it that way? I can think of a couple. I just wanted to ask you though. One reason might be to graph it. Like, this is something I don't think you know how to graph, as simple as it might seem at first. This doesn't seem like something you know how to graph. And yet something in this form does seem like something you know how to graph. It's a good reason. I don't know. Oh, you're thinking already about how I'm going to make this happen? Or wait, or what? Are you saying over here? Yeah, that's actually more of an observation that helps us. I don't know which form is better for the cosine difference formula. You're right. I mean, the cosine difference formula can be thought of as you look at this expression. That's actually how we're going to connect these two expressions. We're going to use the cosine difference formula in a second. I can think of another reason too, but we can cross that bridge. I just thought I'd ask before you like blindly hold my hand and go into this. You might be like, there is maybe a good reason to do this. There are a couple. Graphing is a good enough reason though. Maybe we'll start with that. All right, I'd like you to notice something, so I want to make sure I support that claim that I can really write one of these in terms of the other. I'd like to be able to find that C and D value to make this happen. Was that a question, Crystal? Or Kai?
No, I just realized something. So
yeah.
like the first thing you could do is maybe try and do the cosine addition formula since it has cosine minus sine, and that can just be transferred to the cosine addition formula, and then you can try and do the cosine difference formula. I think.
You mean looking at this expression here?
Yeah.
Yeah, I think that expression does have hints of the cosine difference or the cosine sum formula, doesn't it? Like it has a cosine and a sine in it. It seems like maybe you could go there, and that's exactly what I'd like to have you first notice. Can you, again, just completely devoid of context here? Isn't this true? Stare at this for a second. It doesn't matter what context. We're not talking about this problem necessarily. I'm just talking about just in general. It doesn't matter what C and D are. Can you just look at that and verify that that's true?
Yes.
What is that? That's just simply a cosine difference formula, yeah? With another C thrown in everywhere. But whatever. Multiply it whatever you like by C, that's great. I'm only going to do a cosmetic change and do a little coloring here on that. I didn't really change it at all, I promise. I'm just coloring it here to emphasize that in red, we have that whole piece there, C cosine D. That's a constant. That's just a number. C is a number, D is a number, so therefore C cosine D is another number. There's no variable in that red part. Same with the blue, right? So I'm just trying to highlight, literally here, highlight the fact that we just have a constant times cosine plus a constant times sine on the left side. And that may already go almost all the way toward showing that what we have here is what we have here. I mean, do you see it yet? If c cosine d is a constant, well, maybe that constant is 3. Yeah? Like, maybe this thing is 3, and maybe in blue, c sine d, maybe that's -4. You feel me? Okay. That's kind of where we're headed with this, right? So, just for the sake of clarity, for now, let's rename that c cosine d. Let's rename that a, and in blue, let's rename that b. Okay, so I just renamed the constants. I don't know that you actually do need to introduce another letter in here or not, 2 more letters, but just to be clear, like up in the original problem, we mean by a 3, and by b we mean -4. Okay. And then I'd like you to notice something else. Again, completely devoid of this context, this should still be something you can justify completely. Are you ready? We've got a couple things to say about this. I want you to just notice that this is just our definition of a and b that we decided to call them. If you take these 2 things and square them and add them, nothing to see here yet. I think I have an irresistible urge to do that and to factor out a c squared. What do you see? What do you see? Okay, so if it wasn't clear before, we have a relationship between a and b and c. It just comes from the Pythagorean identity, right? That this thing squared plus this thing squared is just equal to c squared. So that's an interesting observation to make, because as soon as we make that observation, we also have a method, if we know a and b, for finding c pretty quickly thereafter, right? Like maybe you already have in your mind what c is. Don't share it with anyone yet. But for the problem we started with, maybe you already know what c is. If it's really true that a squared plus b squared equals c squared. Hopefully we're putting all this on good foundation. We're going to have a method for you to do this. I want to make sure it all makes sense, like why what we're going to do works. Is this so far okay? There's a lot of letters there. Is there anything that confuses you? Want to point to something and say, why did you do this, or why is that there, or something like that? Feel free to ask it. Feel free to ask a question, or play some dance music. Did you like it? All right, so again, just to make utterly clear, how do you find C? Well, if you know A and B, I think we have a little relationship that can get us C then, don't we? We just showed a second ago that regardless of our choice of these constants, A and B, like C will be always this, square root of A squared plus B squared. We can also find D though, if we go back and realize that by A and B we meant these things, remember? And cosine D then is A divided by C, and sine of D must be B divided by C. So, I'm just saying, isn't that true from this? All right, if that's true, and we know A and C, and we know B, and we still know C, we know A and B, which were given to us in the problem, and we just computed C, I think what we're staring at is this situation. We have known to us now the cosine and the sine of an angle D. I think given those two pieces of information, I think you can find the angle, can't you? You know the cosine and the sine of the angle. Okay, so let's return to our example here. There it is. Did you already say what C is? I think a lot of you already know it. What is it? A squared plus B squared, take the square root. And I gave those, I chose those nicely, didn't I? What does it come out to be? Yay. Good. Now D requires, it's a little messy and requires maybe the use of the calculator, but let's first make this observation. The cosine of D is the thing that's on the cosine, the coefficient on cosine, right? Divided by our C value. And the sine of our angle D is the thing on the sine in our equation, -4, divided by our C value. And now, you should be able to give me what D is. You should be able to tell me what that is, using maybe the help of your calculator. Okay? Before you even reach to your calculator and push buttons, maybe you can tell me what quadrant this terminates at this angle. Do you see why we already know without the use of a calculator? I think hopefully you know that whatever answer you give me, go ahead and push buttons in your calculator now, but with whatever answer you give me, you better give me a fourth quadrant angle. Yes? So make it happen. Go. Grant has a question. Either one works. If you choose a -5, then you will have you'll be thinking of the other quadrant, right? And when you're done, you'll have to also have C be -5. That will actually work too. So you can do it your way. Okay. Really just be out of phase from all of us.
The square root function is a one-to-one function.
What is the square root? Oh, yeah, no, she was just saying since a squared plus b squared equals c squared. That's where we got that from. Technically, it should be able to be one angle.
Yeah.
Often think of
Is it gradient?
you don't actually have to. It works just fine.
Good job.
Yeah, this is like right, yeah. How do you know that must be incorrect? Yeah, what we just discussed. Yeah, make sure your angle is a quadrant 4 angle. Yes? Because we said it would be.
Oh, this is what
Yeah. All right, let's hear from you guys. I'd like to hear what you got for D. Here we go. Grant, talk to me. What's D? How'd you get it?
I got 5.3.
Is this? Are we talking radians, you and me?
Yeah.
Okay, cool. I didn't actually specify the question, so anything is fine. Anything correct is cool. You did in degrees? Cool. Can you say it one more time, Grant? D is approximately equal to 5.3.
5.356.
All right, so how about 5.36 approximately radians? All right, I'll just so you don't need to write radians, but I just to make sure we talk to other people who are doing degrees. That's in radians. I just want to specify. Okay, how'd you do it?
I did inverse cosine of 3/5. But that's in the first quadrant, so I just did 2 times against that.
Okay, I think I agree with his methods. Do you agree with his methods? He said I got a first quadrant angle when I typed this into my calculator, and so I just did 2 pi minus that. to get the other piece or something. But geometrically makes sense. I think he's right. Does anyone have another thought process? I'd love to hear from a couple people here. How did you come up with an answer for D? By the way, that's not necessarily the only way we could have written down what D is, maybe. So, how else did you do it besides what he kind of said? I don't know. Did you have another method? Everyone did that. Everyone did cosine of 3 inverse of 3/5. And then did 2 pi minus that? Is that what everyone did? You did sine inverse? And you have to do sine inverse of negative 4/5. And that gave it to you, you said that gave you the answer right away. Negative 53.1 degrees. All right, that's a great answer too. Keep in mind that anything coterminal to our angle would be fine, yes? And degrees are fine, radians are fine, whatever you want to write it in. So that's great. Notice, I think that's interesting though, that if you use sine inverse, you don't have to do any adjustment. Your calculator just hands you the answer. Why? Why does sine inverse give you the answer right away and cosine inverse doesn't? Chris, do you have an answer to that?
Because the fourth quadrant actually has a negative sign, that's why.
Okay.
I think that's part of it, but I don't get the.
Yeah, I think that's part of it too. Yep, me too. Yeah, that's right. Do you remember anything from last unit that might come to bear on this conversation about? Yeah, what is the range of inverse sine? Isn't it negative to positive pi over 2? Sine inverse. So if you want a function that will output for you a fourth quadrant angle, sine inverse does. What's the range of cosine inverse? Just to refresh your memory. Yeah, 0 to pi. It doesn't make sense to have it be negative pi over 2 to pi over 2 because that repeats values, doesn't it? For cosine, you get the same values in quadrant 4 as in quadrant 1. So that's the conversation I know we've had. Here it comes again, though. Okay. So it does make sense maybe if you have the choice to pick sine inverse if you want, though there is no harm in using cosine inverse as long as you understand what you're doing and you adjust afterward. Right. All right, so our final answer is 5 cosine of x, how do you want to write this? Minus 5.36 plus 53.1 degrees, something like that. A couple different ways you could write that. Okay. And by the way, just to do a little reality check, just to check my theory, I developed all this theory on the last slide, and you're like, okay, I think I get it. But if you want to just do a little reality check, actually use the cosine sum or the difference formula, I guess, either one, to expand this out again and see that you get the thing we started with. Yeah.
Okay, so does it specify a specific range that P has to be in, or can it just be anything that's coterminal? So
anything coterminal, that would be fine.
So it can just be 53.1 degrees plus 36 degrees n or something.
Plus 316, yeah. Yeah, so you could write another good answer that a lot of people had out there, full credit, would be 5 cosine of x minus 306, or whatever it is.
Yeah.
You know, fine, yeah, absolutely. Yeah. There's no need to write it in terms of all of them, though. Just pick one, it's fine. Yeah, Brent? Oh, yeah. This is interesting. You should think about why Bryn's answer works too. What was it? X minus?
2.21.
Is that radians?
Yeah. I have an
All right. Oh, wow. She's just ready. Well, here, I'll read it. So, see if you can figure out why Bryn's answer actually deserves full credit too. What's the minus? Think graphically from last unit. Think however you like to make sure. See if you can figure out why her answer works too. It's very interesting, actually. Very different than any of your answers. It's like 180 off of our answer.
180 inside and 180 off.
Yeah, but then you got like this. Yeah, right. She's out of phase by 180 degrees with us, but that's okay because she also like flipped it. Walk a different path, she says. Okay. All right. This one's for you guys to try right now. Go ahead and try that one, and no calculator needed on this one. Let's not use a calculator.
Wow, I wonder what's
do you think C is? What do you think C is?
Yo, I was looking through my spreadsheet. It's found my application.
Oh, wait a second.
No, I'm not reading this. At least you have it.
Oh yeah, I like L's
Pretty often about it. It's so funny. Express negative
3 hours.
that's stupid. It's good. Oh, it's
Oh, wait a second. Oh, so negative 1 is in
Like 1 over
what's cosine negative 1?
guys, I'm kidding. Oh, you I have no idea, but it looks somewhat familiar. Really?
Cosine D is
I hope so, or else I don't know. I don't get that.
okay. So what I did was, so first I found C, right? And that's 200, and then that
Finding C is a little bit of a trick here. It's like some people are having some algebraic struggles with just even finding C.
Hey, you might be wrong, you know.
Oh my.
Oh wait, I'm not finished.
I told you that.
Plus 45. It's already off.
Is there another nice way to write for 200s? I mean, it's not a demand we have, but it will make the subsequent work easier. Like, you really do need to make that observation at some point. By the way, if you're ever in a situation where you're asking, hey, I've got a triangle with side lengths 10 and 10, what's the right triangle? What's the other side length? Isn't it always 10 root 2? Or in the general case, A, if it's A and A, 45, 45, 90 triangle, isn't it always A root 2? So you can just skip all the work and just write down, oh, I already know it's 10 root 2 if you like to. Okay? All right, well, what's D? Listen, guys. Listen, please. Let's come back together. I think a lot of you have figured it out yet, but we need to keep going here. Is it obvious what angle has a cosine of this? Maybe, hey guys. Is it obvious what angle has a cosine and sine of these things? It is once, I think you write it this way, right? What's D? What angle has a cosine and a sine of negative 1 over root 2? Yeah, in radians, 5 pi over 4, or if you want to do it in degrees, you can too. I saw some people doing that. Fine, I didn't specify one or the other. So we finally have our answer. It's 10 root 2 cosine of x minus 5 pi over 3, 4 is what I meant. And that will be our final answer then, right? Okay. Let me at least set you in the right direction to solve this problem. We need to head out in a second, but let me just like... Yeah, you know what Greek letter that is? That's the Greek letter psi. Psi. Okay. So here, I think it would benefit us if we're solving this equation to have, right now you don't have a way in on it. But if we rewrite it in the form that we like, and we still need to figure out what d is, don't we? Then we'll be able to solve that, won't we? Right? Divide by root 13, take the inverse cosine, and then add whatever this number is, and we'll have our answer.
He's taking it.